All right, I said you must check if you are doing the other ones as well, because I'm only focusing on sine and cos. All right. Okay. Then we're going to have to deal with this one. So, all right, so let's deal with this one. First, I have dy divided by the dx equals 2. Okay, that sign has a squared. I don't like to put a squared in that manner. I delete it. I parenthesize the sign, I square it. Same thing with that one, so that it is clear where the squared is. Can you see it's making sense now? You've got the power rule now. Then the 2 comes here at the back, multiply by sine of x, because I'm supposed to put it in bracket and say 1. No need for 1. I leave it like that. Then times by the derivative of what's inside. First, the derivative of x is 1, and then I must change it to cos. So I don't need to put that one. So it becomes cos of x. That is the first term. The second term, I'm deriving, it's a power rule, is going to be 2, and then cos of x, like we said, it was supposed to be parenthesized to the power of 1, but it doesn't help at all. Then I need to derive the cos. I said I switch the sign. That positive must change. It becomes minus. Then I derive the angle, which is just going to be 1. Then switch it to sine. So it's going to be sine of x. Are they cancelling one another, these two things? How much are we getting? We're getting a 0, isn't it? We can actually go back and say sine squared plus cos squared. We know it is a 1. It's a constant. The derivative of 1 is a constant, must give us 0, which is the truth. Yeah, there was another one. I wanted to change it. I did not. Wait, I don't know where it was. It was this one. Remember this one when we're doing limit as x approaches 0? It was the one thing. Yeah. Yeah. All right. But we're keeping it. If you know what it is, you can simplify it. You can predict the answer. But right now, we're just keeping them as they are to get a practice with the sine and the cos. All right. So this one, dy all over the dx. All right. Well, derive the numerator. Well, it's going to be 0. Times by the denominator, which is cos, times by the denominator is going to be 0, fine, minus, keep numerator, times by the denominator, it's a cos, I need to switch the sign, so at the top becomes plus, derive the angle, so it's going to be times 3, and then change it to sine, so it becomes sine of 3x. Then the bottom must be squared. So I'm gonna write cos squared of 3x. So maybe I can make it look beautiful. So it's gonna be 6 at the top, sine of 3x, and then let's divide that by cos. I can let me write it twice. Cos of 3x. I wanted to square it, and then cos of 3x. Remember, that means it's squared. Cos 3x is squared, correct? Yeah, I'm just trying to say to you, you could, if you want to. What's in the box is a tangent. Can you see that? Yeah, so you can have 6 tangent 3x all over cos of 3x. You can do that. But no need to. Just you can keep it as squared for now. You keep it as that one in the bracket squared. That will be that. But you can